18.3 Special Products of Binomials. So we have, the reason these are considered special products is because we have a binomial that is squared. Now, one of the misconceptions here is that, if it's squared, you just square the first term, square the second term, get your answer. And it's totally wrong, so please don't fall into that trap. So they are demonstrating that here by doing the algebra tiles again. So it's 2x, so you have an x and an x, plus 3, so you have 3 positives. And then the same thing here, because it's 2x plus 3 times 2x plus 3. Now, using algebra tiles, if you multiply this out, again, right here you get a square. And then here you're going to get a square, because we're multiplying. 2 rectangles make a square, 2 rectangles make a square. Then here you're going to get a positive rectangle, and a positive rectangle. Then you come down here, you multiply rectangle times rectangle, and then again you get a square, and you get a square, and then you're going to get a rectangle, and a rectangle, and a rectangle. And then here you get a rectangle, and a rectangle, and then you get a constant, and a constant. And you see it's a whole lot more than what you initially thought as far as multiplying it. So you could go through, and again, this is why I think the algebra tiles get somewhat cumbersome, because it's a lot to do. However, it does demonstrate the point that we have here, which is when you multiply, what do we have here? We have 4x squareds. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. And then we have right here 9 constants. So what I'm going to do is basically go through the same process here, but I'm going to do it using a Punnett square. So what I'm going to do is make my square. Now I have 2x plus 3. Now I have 2x plus 3. Do my products here. So 2x times 2x would be 4x squared. 2x times 3 would be 6x. 3 times 2x would be 6x. And then 3 times 3 would be 9. Here are my like terms on the diagonal again. And so here I end up with 4x squared plus 12x plus 9, the same thing I got before. Now, the thing I like about the Punnett square here in doing it this way, because it does lead us to a shortcut rule, which is whenever you have a binomial that is squared, what do? You take the first term and you square it. You take the second term and you square it. So what do you do to get the middle term? You multiply these and double. 2x times 3 would be 6x. You double that and you get 12x. Now, why do you double it? Because if you come back over here to the Punnett square, you have 2 6x's. Why do you get 2 6x's? Because you have a 2x plus 3 and a 2x plus 3. When you multiply that, you get 6x, you get a 6x, and you have 2 of those. So again, the shortcut, take the first term, square it. Take the second term, square it. To get the middle term, you multiply these and double. Now, the last thing you could do is what we've talked about before, which is you could just go through and do distributive property. So you could write 2x plus 3 squared is 2x plus 3 times 2x plus 3 You could do FOIL at this point, or you could do 2x times 2x plus 3, and then take plus 3 times 2x plus 3, and then work it out. And the thing we said about distributive is it works for all products of polynomials, doesn't matter what type. So basically here they give you another way of doing this problem by doing what I just told you a second ago, which was the shortcut. You take the first term, you square it. You take the second term, you square it. To get the middle term, you multiply these and then double. So again, it's completely up to you how you want to do these problems. One question this does ask that I think is a great one, because we'll come back to this. In the perfect square trinomial, x squared plus bx plus c, what is the relationship between b and c? Okay, so let's do this your turn problem, and then let's talk about how that relationship exists. So for this one, number 5, I'm going to just do the shortcut. So take the first term, square it. Take the second term, square it. So that'd be x to the 4th, because power to a power. 2, you multiply. And then to get my middle term, what I do, I multiply these two, which would be 4x squared, and double it, which is 8x squared. So what is the relationship going back here between b and c? Okay, well, for this particular problem, I need to rewrite the order in standard form so I can see this comparison, because my variable has to be in the middle and my constant has to be last. So what's the relationship between b and c? B is how much of c? Well, it's exactly half of c. One of the things to note, c here must be a positive, because whenever you square something, you always get a positive. So let's do this next your turn. Again, whatever method you want to. In this case, I'm going to do the Punnett square. And again, it's just another way of doing it. So I have negative x, positive 3, negative x, positive 3, multiply. So negative x times negative x gives me a positive x squared. Negative x times a positive 3 gives me a negative 3x. Positive 3, negative x, again gives me a negative 3x. And then positive 3 times positive 3 is a positive 9. Again, there are my like terms on the diagonal. So I simplify and I get x squared minus 6x plus 9. Okay, now we look at this relationship, and what's different? Well, here we have 9, and here we have 6, but 6 is not half of 9. Okay, so what does that mean? Alright, well, let's go back. What did we say about these numbers? How did we get those? We're taking the term here and we are squaring it. So if we're squaring it, let's think about what's the square root of 16? The square root of 16 is 4. Well, what's the square root of 9? The square root of 9 is 3. Now there's a relationship that works for both of these, which is, in this case, 8 is 4 doubled. 6 is 3 doubled. Now we're back to why we double that middle term. Okay, so it's not the fact that it's just half of that or anything like that. It goes back to the whole relationship. This is a square term. This is double the product of your two terms here. The product of these is because that one is squared to get that. And again, that's going to be valuable to us later on. So what exactly changes when this is a minus? Nothing, outside of the fact of your middle term becomes negative. Now, why does your last term not become negative? Well, what we said previously, if you take a negative 5 and you square it, anything squared becomes a positive. So let's go ahead and do the your term problem here. And I'm going to do it again using the shortcut. So what do? I take the first term, I square it. So that would be 16x squared. I take the second term, I square it. Again, it's negative, being squared would be a positive 9y squared. Then how do I get the middle term? I multiply these, which would be a negative 12xy, and double that, which would be a negative 24xy. So the only difference is here, because that's a minus, my middle term here is a negative. Then we have this other case, which is called the difference of two squares. Why is it difference of two squares? Well, it's multiplying a positive times a negative. And again, I think the best way to demonstrate this one is to use the Punnett square. So I'm going to take number 11 for the year turn, and I'm going to use a Punnett square again. So here I have a 7 and a positive x. I have a 7 and a negative x. So one's a positive, one's a negative. I'm going to multiply those. So I get 49. I get a negative 7x, a positive 7x, and then a negative x squared. Well, what happens here on the diagonal? Those are like terms, but what are they? They are opposites. One's a positive 7x, one's a negative 7x. They're going to cancel. So what am I left with? I'm left with 49 minus x squared. Again, what is this called? This is called a difference. Okay, difference of squares. What do we square to get 49? 7. Why? Because it was 7 times 7. This is a squared because it's to the second power, but it's also because it's x times x. It's the same thing times itself. So anytime you have a case where you have the same exact binomial multiplied times itself, just one is a positive, one's a negative, then what's going to happen? Well, that middle term is always going to cancel out, and you're going to be left with difference of squares. So again, they have a modeling here doing difference of squares, or the product of itself being squared, whatever the case might be. Okay, so we're going to skip to the year turn problem here. And it's very important you read this carefully because this can be a confusing problem. What do we have? We have a square, and this is important, a square patio. So I'm going to draw as best I can a square patio, okay, of side length x minus 3. So this is x minus 3, this is x minus 3. Since it's a square, I know all the sides are the same. Now, what it's surrounded by is this flower garden of uniform width. Okay. Now, what it's asking us to find, well, first of all, it says the side length of the entire square area that includes the patio and the flower garden is x plus 3. So this is all x plus 3. Now it says write an expression for the area of the flower garden. Now remember, the flower garden is just this part in here. It's not all of this in the center, because this is a patio. That's all concrete. So how do I get this? Well, I'm going to talk to you about something. Somebody's going to watch this video, your parents might, and they'll laugh, but I'm going to talk to you about finding what's called the a-hole. So what do I mean by that? The area of the whole thing is equal to the area of what? The patio plus the area of the garden. If I take the patio portion and the garden portion and add those together, that gives me the area of the whole picture. Okay, that's what we mean by finding the a-hole. So I can find the area of the whole thing. How do I find that? By using x plus 3 squared, length times width. I can find the area of the patio by taking what? X minus 3 squared. What I'm looking for is the area of the garden, so I'm just going to call it A. So now I have an equation that I can work out. So if you go ahead and multiply this out, and I'm going to do that very quickly since I know what the products are going to be. This is x squared plus 6x plus 9 equals, on the other side, I'm going to get x squared minus 6x plus 9 and then plus a. So I'm looking for a. So what am I going to do? I'm going to subtract this x squared. So what happens here? Boom, boom, cancel. I'm going to add a 6x. It's going to happen. Those are going to cancel. Over here I now get 12x. And then I'm going to subtract 9. Subtract 9, what happens? Boom, boom, those cancel. So I have now 12x equals, and on the right side, a. So what do I have? I have an expression for the area of the garden. So the area of the garden is 12x feet squared. So whatever x is, that would tell me how much the area of the garden is. Now it's a little more complex, but the math itself is relatively simple as long as you know all the rules. So real quick, let's review. When you're adding like terms, what makes them like terms? Same variable with the same exponent. When you're multiplying, okay, what's the one method that works for all things? You can do distributive. You could use Punnett squares, Punnett rectangles if you want to help you multiply. You can use algebra tiles. You can use the shortcut in this case for multiplying or squaring a binomial and do that. There are lots of different ways to do this. The thing is, you got to be comfortable with it. This is something that's very, very, very important going into our final couple of modules that we're going to be doing, is understanding how polynomials work. So you're going to be doing homework here on page 872, and you're doing numbers 1 through 25 odd.